So this covers all the formulas related to the theory of failures, whatever we have seen. And using these formulas, we are going to solve problems. There's three questions, like one, two, and there will be three questions that we'll be solving it today. With respect to the one measure stress, maximum shear stress, octahedral shear stress, and this maximum principal stress is also called as a Rankine theory. And we are also going to see the problem with respect to the shear stress theory or a gust theory. And the shear energy theory is also called as Henke von Mises theory. And the maximum strain theory is also called as Saint-Venant theory, where you also have some the, the formulas here. And if in case in the exams, if any alternate name is been given, you need to understand. Say for example, instead of maximum strain theory, sometimes Saint-Venant theory might be mentioned in the problem. So you don't need to get confused, and according to this, you can use the formula and you can solve the problems. And similarly, say for example, instead of maximum principal stress, there might be a question where it will be mentioned as Rankine theory. So again, you don't need to get confused. What is this Rankine theory is all about? Again, it's based on it's basically a name of the inventor who created the derivation and who solved this, and who made this equation basically. And similarly, say for example, when it comes for some alternate names, you no need to get confused. Let us solve the three problems what I have mentioned. If it will be better if you have a calculator during the session. Just a second. Meanwhile, I'll also take the calculator so that we can solve the answers together. Let us go to the first question. Just go to the whiteboard. I'll just go, but before going to the whiteboard, I'll just share the question. You can write down or you can note down the given data based on which you will solve the problems. A machine element is subjected to the stresses sigma x. It's a given value 60 MPa. Sigma y, stress acting in the y direction, it's going to be 45 MPa, and tau xy is going to be 30 MPa. So for this, it's very important that we need to find the factor of safety. This is the problem statement. We need to find the factor of safety, and the material they given here is C45 steel, which is going to have a yield stress as 353 MPa. If in case if there are some assumptions, like if in case if the yield stress is not been given for any of the material, you can also assume some other values based on the design data book. Even if in case the table I will be giving, if in case if the value is not been mentioned in the problem, okay. So here the value has been mentioned here as 353 MPa. So using the theory of failures, what we have seen so far, so it's you have to use all these theories, and we need to find the factor of safety. This is the first problem statement. Let us solve this first. And I'm just going for a whiteboard. Okay, so let us write a given. Oh, sorry, there is some issue. I could not able to. Yeah. Um, okay. So these are all the given values. So sigma x is been given as 60 MPa. So unit is also very important, 60 MPa megapascal, and sigma y is given as 45 MPa, and yield stress tau xy is given as 30 MPa, and yield stress sigma x for a material called C45 steel, it is given as 353 MPa. And the Poisson ratio, which is very much required when you are going to solve the maximum strain theory or a Saint-Venant theory. Okay, there is the Poisson ratio we need to consider. Okay, if in case if it is not been if not been given in the problem, then you can assume the value, and this Poisson ratio is being considered as 0.3 for the material C45. What is been considered here, and this is very much important when you're going for the Saint-Venant theory solution, basically when you're going to solve the problem. So now let us go to the solution. The first question is going to be the maximum principal stress theory. So, and I also told that maximum principal stress theory is also called as the Rankine theory, and the formula here for that is okay. I think the next page it's not coming, so I think every time I have to erase. So let us, what is been asked here is the factor of safety is been asked. Okay, so the factor of safety is nothing but the yield stress, ratio between the yield stress to that of the equivalent stress. So here we are going to follow, you are going to find out the equivalent stress first. Okay, this yield stress has been already given in the problem. Okay, it has been given as 353 MPa. Okay, so once if we find the equivalent stress, then we can easily find out the factor of safety. Okay, and we have the equivalent stress formulas for each and every theory. So the first equivalent stress, the formula here is for a maximum principal stress theory or for a ranking theory of equivalent stress. So sigma E is equal to sigma x plus sigma y plus root of sigma x minus sigma y the whole square plus 4 into tau xy square. Okay, um, so considering this, what you have is sigma x is 60 and sigma y is given as 45 as per the problem, plus root of 60 minus 45 the square, which is we can directly, I'm just giving as 15 square plus 4 into tau x square is 30 square. Okay, you can tell the values how much you are going to get. So it is going to be 105 plus tau of yeah, you need to find again. You have to go to the, you can use the calculator. 15 square is going to be 225 plus 4 into 30 square, which is 30 square is nothing but 900 into 4 will be 3600. 3600 plus 225, so you need to take the square, so it is going to be 61, so this value is going to be 61.8 plus 105. Okay, so you have to use 1 by 2. The formula here is 1 by 2 into sigma x by sigma y. So this is the formula. So what the value we are going to get is 166.8. The overall value is going to be 166.8. So I told it's 1 by 2 going to be sigma e equal to 1 by 2 into sigma x by plus sigma y plus root of sigma x minus sigma y the whole square plus 4 into tau x y the whole square. So what we are going to get, hope my calculator is also visible. You can also confirm. Yeah, so it's going to be 166.8 divided by 2. So it's going to be sigma e is going to be 83.4 MPa. Okay, and next is going to be the factor of safety. I told you factor of safety is nothing but the ratio between yield stress to that of the equivalent stress. So we have found the equivalent stress using the principal stress theory is going to be 83.4, and as per the given problem, sigma yield means the yield stress is going to be 353. So now what I'm going to do is I'm going to divide the 353 to this 83.5 83.4 in order to get a factor of safety. Okay. uh, so now what I'm going to do is 353 divided by 83.4, which is going to be the factor. Okay. The factor of safety is going to be 4.23. Okay, so this is the answer for the first given problem, and the given problem here is find the factor of safety using the maximum principal stress theory. And the next, we will go to the next problem, means next problem theory, which is nothing but maximum shear stress theory. Hope the calculator and the whiteboard is visible. um, if you have any clarification, you can just let me know. Just hold here. You're not getting 4.23. Just please confirm if you have any doubt up to this. Okay, thanks for the confirmation. Okay, so now let us go to the second one, which is nothing but the maximum shear stress theory. And this maximum shear stress theory is also called as Guess theory of equivalent stress. So again, here we are going to find same sigma e we are going to find here, and once we find the sigma e, then we can find a factor of safety. And this sigma e is going to be root of sigma x minus sigma y the whole square plus 4 into tau xy square. It is really easy, and we have seen the same answers in the previous thing also. Sigma x is 60, and sigma y is going to be 45. So 60 minus 45 is going to be 15 square, plus 4 into we have seen tau xy is going to be 30 square. So what we have seen is 15 square is going to be 225, plus 900 into 4 will be 3600. So when you solve this, so it is going to be root of 3825. So the square root of this 3825 is going to be 61.84. Okay, so 61.84 is going to be the equivalent stress using the maximum CSS theory or August theory. And now again going to be a very interesting called factor of safety, which is defined as the ratio between yield stress to that of equivalent stress. So what I'm going to do is 353 is the yield stress as per the given problem, and 353 divided by the equivalent stress. Okay, and the equivalent stress is what we got out of this is going to be 61.84. Yeah, and the factor of safety is going to be 5.70. Okay, so the factor of safety using the maximum CSS theory or a guess theory is going to be 5.7, and in the previous formula using a maximum principal stress theory or a ranking theory, we got the factor of safety as 4.23. Now let us go to the third one called as per the given problem. Okay, so I am going to the problem again. Yes, so we have seen the first two solutions. Now I'm going to see the third factor of safety. We are going to calculate the third factor of safety using the shear energy theory and then using the maximum strain energy theory, where we are going to take the Poisson ratio as 0.3. Let us go to the third one, the shear energy theory, and this shear energy theory is also called as Henke von Mises theory. I request parallelly from your side also you can check using the calculator. If in case slight mistakes from my side also you can correct it. Okay, let us go to the third part, which is nothing but the shear energy theory. And according to the shear energy theory, the equivalent stress is equal to root of sigma x square plus sigma y square minus sigma x into sigma y plus 3 into tau xy square. We know that sigma x is going to be 60 plus sigma y is going to be 45, and the sigma x into sigma y is going to be 60 into 0.5 into 45 plus 3 into what is tau xy acting in the xy direction, so it is going to be 30. Okay, so you know this 30 square is going to be 3600 plus, so I need to have the square root. Yeah, sorry, I was on mute, sorry. So 2700 plus 3600, so you know this 900 into 3, it is going to be again going to be in 2700, so these two get cancelled, so the square root of 3600 plus 2025 will give you the value plus 3600. So this we need to take the square root, which is coming as 75. So what answer you have done is also correct. Now again we need to go for a factor of safety. So you know this factor of safety again, the ratio between yield stress to the top equal stress. So yield stress is going to be 353 divided by 75. Here the value is going to be 4.7. Okay. So let us solve the last part of this problem. So we need to find the equivalent stress using the maximum strain theory or a Saint-Venant theory. According to this theory, the formula is going to be 1 by 2 into 1 minus Poisson ratio, which is also been given, to sigma x plus sigma y plus 1 plus Poisson ratio into root of sigma x minus sigma y square, y the whole square, plus 4 into tau xy square. And you also know this sigma x minus sigma y the whole square plus 4 into tau x square, this is nothing but the maximum CSS theory or gust theory. Okay, this, you know this one. Okay, so this so you will directly calculate the value here. Okay, and the value what we got using the maximum CSS theory is 61.84. Okay, so I'm just reducing the time of calculation, and now this sigma e is equal to 1 by 2 into 1 minus 0.3. Okay, it's going to be 0.7 into sigma x plus sigma y. 60 plus 45, it's going to be 105, and 1 plus 0.7. Okay, so 0.3 is going to be 1.3. Okay, so now we will solve this one using calculator. 76.9. Okay, the answer is correct. Yeah, let us re-verify it once again. Point 0.7 into 105 into 1.3 into 60. 1.84. I'm not getting the value. Just a second. 105 into 1.3. Is there any calculation error from my side? But I'm not getting the 76.95, but the answer is correct. If I'm not wrong, the sigma x minus sigma y whole square plus 4 into tau x square, directly I've taken the value, which is going to be what we have already solved using the maximum CSS theory. It's going to be 61.8 plus missing. Okay, so this is going to be plus. Okay, I was directly taking it as a. Oh, thanks for the confirmation. Okay, so which means 61.84 into 1.3 will give us 80.39. So 0.7 into 105. It's going to be 73.5. So this plus this divided by 2 will give you the value. So 73.5 plus 80.39, which is going to be 153, and divided by 2 will give you 76.945, which the answer what you got and what I got and what is there in the answer all are going to be same. Okay. So this is the answers that we got with respect to the equal-stress, and again we need to calculate the factor of safety, and factor of safety is nothing but the ratio between yield stress to that of the equal-stress. So yield stress is given as 353. 353 divided by 76.94. So what is the 353 divided by 76.9, which is equal to 4.559. This is going to be a factor of safety. So let us go to the next problem. So it's also going to be similar one. And before going to the next problem, so here you know this Poisson ratio. Okay. So this Poisson ratio is nothing but the ratio of a proportional decrease with respect to the lateral measurements to the proportional increase in the length in a sample of the material which has been elastically stretched. So you can also tell us lateral strain to that of longitudinal strain, the ratio between the lateral strain to that of the longitudinal strain. Okay. Uh, with respect to the material point of view, when you're taking the solid mechanics or the material aspects, this Poisson ratio is going to relate to the deformation of the material in the direction which is perpendicular to the load. When you are applying the load, in particular in with respect to the directions perpendicular to the application of the load, where you are going to get the measurement, and which is nothing but the ratio of the lateral strain to that of the longitudinal strain. And this Poisson ratio, different material will have the different values. Okay, so here we have taken as zero point 0.3, and this Poisson ratio will range between zero point 0.0 to zero point 0.5, and again this will also vary with respect to different materials. I said where you have the rubber will have the different uh, this rubber is going to be a part of soft material, for which the bulk modulus is going to be higher than the shear modulus, and you can take the Poisson ratio nearing to zero point 0.5 for a soft material. And say for example, when you're taking the polymer foams and those aspects, the Poisson ratio will be very near to zero, as the low as the cell what you are going to use, or as a load what you are going to use is going to get collapsed during the compression. Normally the solid material will have a Poisson ratio between zero point 0.2 to 0.3, and This has been named, the Poisson ratio has been named after a French mathematician and physicist named Simon Poisson. So he is the inventor of this. And you can also define this Poisson ratio for any material as the ratio between transverse strain to that of the axial strain. You can also define in that way. I think I have also mentioned those things as a part of the introduction. Okay. Uh, so in short, you can tell this Poisson ratio is defined as the ratio of the change in the width per unit width of a material to the change in its length per unit length as a result of the strain. So that's what I mentioned in other aspects as well. Uh, but again, you can also mention here, you can also define in this way as well, which is defined as the ratio of the change in the width per unit width of a material to the change in its length per unit length as a result of the strain. So I'm going to give in two different aspects the definition. Or simply, if you want to define, you can also define as the ratio between letter strain to the longitudinal strain. Let us go to the second problem. Okay, so as I said, three problems we have. So the last one is going to be similar to what we are going to solve. But let us go to the. Okay, so in the next problem, it's a bit here. What they given here is they given the factor of safety. They given the factor of safety, which is going to be 0.298. Sorry, the factor of safety is going to be 2.5. And here they are what they are asking is they are asking us to calculate or determine the diameter, core diameter of the bolt using the four theories. And they also given the Poisson ratio for us to solve the Saint-Venant theory equivalent stress. And using that, we can calculate the diameter of the bolt. And here, as per the problem statement, a bolt is subject to a tensile load. They given the tensile load value as 18 kilonewton. And they also given the shear load, which is equal to 12 kilonewton. And here also they given the yield stress of the material. Okay, they did not mention the grade of the material, but they given the material what is been used is going to have 328.6 MPa. So it can also be close to the C45 steel material. So again, we are going to use these four formulas, but we are going to calculate the diameter of the bolt given the factor of safety here. Okay. So this is the second problem, and the third problem is also quite similar. So instead of solving the two, I think the same data. Okay, so I was trying to take some other values. Okay, let us solve only one problem, which means so both are similar data, similar values. So what they given is they given the tensile load. Okay, they given the tensile load. So tensile load is going to be 18 kilonewton, or you can convert into Newton. It is going to be 18 into 10 power 3 Newton. And shear load, it is nothing but Fs. What they given us for the problem is going to be 12 kilonewton, which is nothing but 12 into 10 power 3 Newton. Yield stress is also given. We are lucky to get directly the values. So it is going to be 328.6 MPa. And they are also given the factor of safety, which is nothing but yield stress to that of the equivalent stress. So what that is 2.5. And now using this you can also calculate the equivalent stress as well. Okay, so it is nothing but sigma ys by sigma e. Yield stress is also, you already know this e value. Okay, so 2.5 into sigma, sorry, sigma ys, already 328.6. So 328.6 divided by 2.5 will give you the equivalent stress value. Okay, so what is the value, like 328 by 2.5? So I can say directly, we can calculate here as well. Sigma e is nothing but equivalent stress. So 328.6 by 2.5 is going to be, let us see one second. 328.6 divided by 2.5 is going to be 131.4, which is going to be the equivalent. Unit is very important, MPa. Now again, the stress is nothing but a force or load by area. Okay, so this is nothing but a sigma x. Okay, the tensile load. Okay, sigma x. This is nothing but the sigma x. They given the sigma x value. Okay, so sigma x is nothing but the stress is nothing but what, the load by area, or the force by area. Sorry. So force is given as 18 into 10 power 3 Newton, and the area is nothing but what, pi by 4 d square. Okay, so what is the problem statement? So here they're asking us to calculate the diameter. Okay, diameter. So you know area is nothing but pi by 4 d square. So with this, you can also calculate the d value, because you know the sigma x value, uh, you know the load value, with this you can calculate the pi by 4 d square, where you can calculate the d value. Okay. Now we are going to use all the four theories to solve, to get what is um, the individual diameter we are going to get basically. And you'll have the four different diameters basically. So you are going to get the different diameter for a ranking theory, different diameter for a maximum shear stress theory, and different diameter you are going to get for a von Mises theory, theory of failures, and finally Saint Venant theory of failure is going to have uh, different values basically, different diameter. Okay. And what you can take here is you can take the diameter which is going to have the high value. Okay. So that that is the way, like when you are going for a design selection, so you can take the diameter which is going to be and there will not be too much difference, there will be slight difference. Okay. uh, so you considering that, you can take the best optimized one. Okay, let us solve the problem. And here they are not given y direction. Okay, normally they give the load should also act in the y direction, right? But here they given only in x direction, so it becomes easy for the problem to solve as well. Sigma y is 0 here in this problem. Sigma y is 0. So if in case sigma y is also given, then again that will also call for a big change. Okay, so let us solve this. So they given the shear stress sigma s tau s. Basically sigma stress is nothing but uh, tau xy basically. Tau xy is nothing but the shear load to that of area. So as per the problem statement, they given the load acting onto the shear load. Basically they given us 12 kilonewton, which is nothing but 12 into 10 power 3. And we can find out the diameter pi by 4 d square. And let us go to the first one. Okay, so first equivalence test formula here is for a ranking theory. The formula here is 1 by 2 into sigma x plus sigma y. You know sigma y is going to be 0, so I'm going to write only sigma x plus root of sigma x minus sigma y the whole square. So sigma y is going to be 0, so only sigma x square will come. Okay, plus 4 into tau xy square. Okay, you know sigma x, you know the formula. But what we have done is we have done the values in terms of a. Okay, in terms of a, area is nothing but pi by 4 d square. And similarly tau x y square, so this is what tau x xy, so this is also going to be in terms of area. Okay, or in terms of d. Okay, so here also you have area, here also you have area, which is nothing but pi by 4 d square. So when you directly solve it, you also know the sigma e value. Okay, we already calculated the sigma e value, where this sigma e is nothing but it's going to be 131. Yeah, it is going to be 131.4. Okay, It is what we have calculated. So with this you can calculate the diameter easily. It's a core diameter. We know that 131.44 is going to be the equivalent stress, which is equal to 1 by 2 into sigma x, okay, which is nothing but the tensile load acting, which is nothing but 18 into 10 power 3 by area. Okay, let us write the diameter later on, plus root of sigma x square 18 into 10 power 3 by a square plus 4 into tau xy square. Okay, so you know tau x square is nothing but 4 into 12 into 10 power 3 by a the whole square. Okay, so everywhere you have a here, a here, a here. So finally when you calculate, so area is nothing but pi by 4 d square. So here we are going to calculate the core diameter of the bolt. So this you can directly find out what is the core diameter of the bolt using the ranking theory of failure. Okay. I'm directly going for an answer because we don't have the sequence here. When I'm writing the values again, the pages is going to the next level, so it becomes difficult even for you to follow the calculation. But again, uh, you can follow the methods using which you can calculate the diameter. So the answer here is going to be, I'm going directly going for an answer. The area is going to be 228.2 as per the solution given in the book. Area is going to be 228.24, and with this you can calculate the DC diameter, core diameter of the bolt, which is going to be, sorry, not 28. Area is going to be 182.59, 182.59, and with this you can calculate the diameter of the bolt DC, uh, where the diameter is going to be 15.25 mm. Okay, you have to solve very simple one where we get the maximum shear stress theory, for which you can easily calculate the diameter of the bolt. In a single slide we can calculate that. I'm going for that calculation now. The maximum shear stress theory of failure, sigma E is equal to root of sigma x minus sigma y square plus 4 into tau x y square. Sigma y is going to be 0, only we have sigma x square plus 4 into tau x square. And with this, we can easily calculate the diameter of the bolt using the maximum shear stress theory. And this sigma E is going to be 131.44. Now you can solve this problem now. Sigma x square. So sigma x is nothing but 18 into 10 power 3 by A the whole square plus 4 into tau xy the whole square is nothing but 12 into 10 power 3 by A. 12 into sorry, I'm really facing difficulty with respect to this whiteboard, so that's why the cursor is also yeah 12 into 10 power 3 by A the whole square. So everywhere you have A, again you can calculate the DC. Uh, you can try now the answers and you can let me know. Maybe will take 5 minutes to solve this. Let me go for a scientific calculator. Just give me a second. Meanwhile, you can also calculate from your side, because if you're going for a scientific calculator directly, we can go 18 to 10 power 3 the whole square. At a time, we can give the values instead of doing the individual level. For your exams also, I prefer you to use the scientific calculator, so it becomes you can reduce the time of calculation also. Just will take 5 minutes, and parallelly I will try to solve the problems using the scientific calculator. Maybe parallelly we can also give the values for diameter of the bolt. What is the area we're going to get, and after that we can use pi by 4 d square to find out the core diameter of the bolt using the CSS theory.